let us see the types of connections in a computer network. Now before we see the types of connection, we will see what is a network. A network basically is a collection of computers, or we can say it is a group of computers which are connected through some kind of a link. Now the reason the computers are connected is so that they can share some data or they can exchange some resources with one another. Next, let us see what is a link. Link basically just a path through which data will be transferred. So it's just a communication path to exchange some kind of a data. Now let us see the types of connections. There are two types of connections. One is point to point and second is multi-point. So first let us see point to point. In point to point there is a dedicated link. Now a dedicated link, meaning the entire capacity of the channel will be reserved for transmission only between the two connected devices. So if the capacity of the channel is reserved for transmission only between the two devices, we can say that the capacity of the channel is not shared with the other devices. So we can say that the capacity is not shared with other devices, only there is a dedicated link between the two connected devices. Next, let us see multi-point connection. Now multi meaning many, so that means there will be many devices which will be connected to the link. So if there are many devices which are connected to the link, then definitely the capacity will be shared between multiple devices. So we can see here that the capacity is shared between multiple devices. Now there are two ways of sharing. One is spatially shared and second is time shared. So if the link is spatially shared, then multiple devices can send the data simultaneously. But if it is time shared, then users will have to take turns and then only send the data.
I'm going to explain you now in theory what the MDB bus is and how it works. You have seen the coffee machine in the first part of the video. So we have somewhere a controller, which is typically called the vending machine controller. This vending machine controller is a cable coming from the coffee machine to all its peripherals. And peripherals, there's a lot. There's, for example, bill acceptors, coin acceptors, credit card terminals. You saw that little key upstairs. These are all peripherals. I didn't bring the coffee machine because it's too heavy. So that coffee machine comes out with a cable which typically looks like this and goes to its peripherals. And the unique property of MDB bus is that you can have multiple of these peripherals. So one taking the bills, one taking the coins, and one maybe taking your credit card. All these readers are peripherals connected to the MDB bus, and of course these peripherals, especially the heavy ones, will need power. So typically you have a separate power source somewhere being part of this bus. That's basically what MDB is about. From the technical part, it's all about these cables with these connectors. And for physical reasons, a lot of the products have two connectors, so you can wire in and out to make a real daisy chain. But don't get fooled, this is all the same signal going on all the same bus. This is the MDB bus, the physical appearance, how you find it in the coffee machine.
Next, let us study physical topology. A physical topology is the arrangement of elements in a computer network, or in simple words we can say that it will tell us how the devices are connected inside a computer network. So there are 5 different types of topologies, but in this video we will discuss only 2 types, that is mesh and star. The other 3 types we will discuss in the next video. First one is mesh topology. Now in mesh topology there is a point-to-point link from one device to all the other devices. Now point-to-point link we have already studied in the previous slide, which means that there will be a dedicated link from one device to all the other devices. Now these devices are also known as nodes. So in this figure there are 4 devices, so we can say that there are 4 nodes. And in this figure there are 5 devices, so we can say that there are 5 nodes. Now in mesh topology there is a point-to-point link from one device to all the other devices. So over here this device A will be connected to B, C and D using a point-to-point link, Similarly, this device B has a point-to-point link to A, D and C. Similarly, this device C has a point-to-point link to B, A and D. And same way, this device D is also connected to A, B and C. So in this figure also, all devices are connected using point-to-point link. Next, the number of links or the number of cables required in a fully connected mesh network is given by the formula n into n minus 1 divided by 2, where n is the number of nodes. Now say for example in this figure there are 4 devices, so number of nodes will be 4. So if nodes are 4, n value will be 4. So if we put n value in this formula, we will get 4 into 4 minus 1 divided by 2, that is 4 into 3 divided by 2. So the answer will be 6, which means that 6 links or 6 cables are required to connect 4 nodes. So if you look at this figure, there are 6 links required to connect these 4 nodes. So if we count, we will get 1, 2, 3, 4, 5 and 6. Let us take another example. Now in this figure there are 5 devices, or we can say that there are 5 nodes. So if there are 5 nodes, n value will be 5. So if we put this 5 value in this formula, we will get 5 into 5 minus 1 divided by 2. So that is 5 into 4 divided by 2, and the answer will be 10. Which means that there are 10 links or 10 cables required to connect 5 nodes. So if we count the number of links over here, the answer will be 10. Next, the number of ports required for each node is given by the formula n minus 1. So for example, in this figure, there are 4 devices. So number of nodes will be 4. So if there are 4 nodes, n value will be 4. So if we put this n value in this formula, we'll get the answer as 3. So which means there will be 3 ports required for every node. So in this figure, we can see that device A requires 3 ports. Similarly, device B requires 3 ports. Similarly, C and D requires 3 ports each. Next, let us take another example. If there are 5 devices, number of nodes will be 5. So if there are 5 nodes, n value will be 5. So which means that there will be 4 ports required for every node. So in this figure, we can see that all these devices A, B, C, D and E have 4 ports each. Next, let us discuss some of the advantages of mesh topology. Now, first advantage of mesh topology is security. The reason mesh topology is secure is because there is a point-to-point link from one device to all the other devices. Now, say for example, this device A wants to send something to C, then it can directly send the data to C without involving any other devices. So the communication will be secure between only these 2 devices, that is A and C, and no other recipient will be able to get the information. Second advantage is that there are less traffic problems. Now the reason for less traffic is the same, that there is a point-to-point link from one device to all the other devices. Now say for example, this device A wants to send data to C and D simultaneously. Then it can send data to C using this link, and it can send data to D using this link simultaneously without causing much traffic. The next advantage is that fault isolation and identification is easier. The reason for this is because there are point-to-point link from one device to all the other devices. So it is easy to identify where is the fault and isolate the fault. Last advantage is that mesh topology is robust. Now say for example, A wants to send data to C, and say suppose this particular link fails, that is from A to C the link fails. Then A can send data to C using any other path, that is it can send this way using A, B, C path, or it can send using A, D, C path or any other path available. So which means that if any particular link fails, then the entire network won't be affected. So let us see the disadvantages. First disadvantage is that mesh topology has a high cost. Now we know that in mesh topology every device is connected to all the other devices. As a result, the number of ports which are required and the number of cables which are required will be very high. Hence, it will have a higher cost. Second disadvantage is that installation and reconnection is difficult. Now, since every device has to be connected to all the other devices and there is a point-to-point link from one device to all the other devices, installation and reconnection will be a problem. Next, let us learn star topology. Now in star topology, there is a point-to-point link to the central controller. Now say for example, in this diagram we have 5 devices, that is A, B, C, D and E. Now all these 5 devices have a point-to-point link to the central controller. Now this central controller which is used is mostly a hub, and hub basically is a multi-port device which is used for connecting the devices. Now this central controller is used to exchange the data. Now say for example, A wants to send data to D, then A will first send to the central controller and then the central controller will send the data to D. Next, the number of links or the number of cables required in star topology is n, where n is the number of devices. Now say for example, in this figure there are 5 devices of 5 nodes. So if there are 5 nodes, n value will be 5. So 5 links will be required to connect 5 nodes. So if you look at this figure, we can see that there are 5 links required to connect 5 devices. Next, the number of ports required for every device is 1. So if there are 5 nodes, n value will be 5 and 1 port will be required for every device. Say for example, in this figure there are 5 devices, so all the 5 devices will need 1 port in order to connect to the central controller. So A will have 1 port, B will have 1 port, similarly C, D and E will have 1 port to the central controller. Next, let us see the advantages of star topology. Now the first advantage is that it has lower cost as compared to mesh topology. Now we can see that in star topology there is a point-to-point link only to the central controller. As a result, the number of cables which are required or the number of ports which are required are much less as compared to the mesh topology. Hence it will have a lower cost in comparison with the mesh topology. Second advantage is easy installation and reconnection. The reason is because each device requires only one link in order to connect to the central controller. As a result, it is easier to install and reconfigure star topology. Next advantage is fault isolation and identification is easier. The reason is because since every device has a point-to-point link, it is easier to identify where is the problem. Also, if any link fails, only that particular link will be affected. Now let us discuss the disadvantages. The main disadvantage is that there is a single point of failure. Now say suppose the central controller fails. So if the central controller fails, then the entire network will also fail because all the devices are dependent on the central controller.
Here is a main cable and a lot of computers are connected to the main cable. This type of topology is known as bus topology. In this topology, all the computers are connected to the main hub or main cable or bus. Data flow in a single direction. It is cost effective. It's used in small networks like in your home. It's easy to expand. But it is slower and dependent on the main cable. That means if main cable fails, then all the other network will fail. These are the computers which are connected in a ring structure, which is known as ring topology. Now in this topology, data flows in unidirectional from there to there, but sometimes it can also happen on the other side. Then it is known as dual ring topology. Now it is unaffected by high traffic. It is very cheap to install, but it is prone to failure. That means any of one computer in a ring fails, then all the network will fail. It's a main bus, and as you can see there are hubs, and to those hubs there are computer connected in a star formation. Such type of topology is known as tree topology, as this is a combination of two topology, bus and star topology. Now it is used in WAN, that means wide area network, easily expansion of node, that means you can easily connect a lot of devices, a lot of other star networks to it. The maintenance of this network is very easy, but it's also central hub dependent. That means if main bus fails, all the network will fail.